Alright guys, how are you doing? This is our last lecture of the course. I hope you're excited. We're almost done. It is kind of a nice one to finish because we will go over some of the stuff we learned at the beginning in a sense, and hopefully it will help to tie it up a little bit for you. I'm not gonna go into everything I would normally go in class again because, as you know, the class lecture is an hour and 20 minutes, and now we're only going to do maybe 30 minutes at the most. But let's look at some of the most important stuff. So what is it about? It's called argument forms and fallacies. Well, you should know argument forms by now. Again, remember, argument form is like a skeleton of the actual argument. You can extract it. Remember, we did that. We were extracting argument forms. And then you can use just simple letters and symbols, which you also have learned at the beginning of chapter 6, to graphically represent this particular argument. Now, once you do that, it actually makes your jobs much easier to figure out whether the argument is valid or invalid. Because remember, we actually were talking about deductive and inductive arguments at the very beginning of the class. So let's just refresh our memory on that. We have deductive arguments and we have inductive arguments. Remember that deductive arguments can be valid and invalid. Inductive arguments, on the other hand, are strong and weak. And we dedicated chapter 3 to understanding how to determine whether inductive argument is strong or weak. Because remember, they are based on probabilistic reasoning. So we cannot really have this kind of mathematical procedure to figure it out. Such as, for example, inductive argument from authority. Just because it's from authority itself doesn't tell you whether it's strong or weak. You have to look deeper than that. You have to look at the content. What authority is this? Is this your next door neighbor? Is this a world-renowned scientist? Is he an expert in the field? This is the kind of questions we were asking in chapter 3. Now we're dealing with deductive arguments. Deductive arguments give us much higher degree of certainty. So if they are valid, we know for a fact what? We know that if the premises are true, then the conclusion will always be true in a valid deductive argument. And if it's not the case, then it is invalid. So this is what we were dealing with in chapters 4 and 5. In fact, 4 was preparation for 5, but remember in 5 we were drawing those Venn diagrams, trying to figure out categorical syllogisms. Are they valid or invalid? But we still left some of the other types of syllogisms, hypothetical, disjunctive, until chapter 6. Now we worked on truth tables. Truth tables actually show you very precisely whether or not it is a valid argument. However, they are long and cumbersome. So this is where we get to this section, last section, 6.6. In fact, what it's about is, if you know particular argument forms, you can immediately see whether or not it's a valid argument just based on those forms. So instead of going through truth tables and trying to figure out all the possible values an argument can have, what you can just do is simply look at the form. Extract the form if you don't have it yet, and then look at it. And that will immediately tell you if the argument is valid or invalid. You should know several of valid forms and a couple of invalid ones. So again, the first one is Modus Ponens. Modus Ponens would be something like this. If P then Q, P therefore Q. So note that this is actually a fairly simple hypothetical syllogism, isn't it? You have your antecedent and your consequent, and then you are what is known as affirming your antecedent. It is perfectly valid argument, and if you use knowledge we just obtained, in the previous section, you can prove it yourself. You can go through it and figure out. So remember what invalid argument would be like. In invalid argument, you would have true premises and false conclusion, right? Now, is it possible here? Ask yourself this question. Well, note that we already have then values for P and Q, right? In order for this to be the case, P has to be true and Q has to be false. If that is the case, if this is true and if this is false, is there any way you will have true premise here? No. Because if this is true and this is false, then by definition, that would be false. So see, that doesn't work. Proving it invalid doesn't work. That means it is valid. And indeed it is a valid argument. Again, the form itself is called Modus Ponens. Remove this stuff. And just by seeing that form, you can immediately say to yourself, it is a valid form. It is Modus Ponens, valid form. If P then Q, P, therefore Q. Remember, P is also sufficient condition. If that condition applies, then your consequent follows with strict necessity. So this is one of the valid forms. Next valid form you should know is kind of like that, also the same principle, Modus Tollens. Modus Tollens starts the same way, if P then Q, but then instead of affirming your antecedent, it actually denies your consequent. It says not Q. And again, through valid reasoning, if not Q, then it would be not P. Again, remember, this is your necessary condition. If your necessary condition is not satisfied, then of course your antecedent cannot be taking place either. Now the book gives you several examples. I'm not going to go through them. You can take a look on yourself, on your own. But this is just the first two. And then pure hypothetical syllogism. Again, that is a valid form. It goes kind of like this. This would be MT, HS. Pure hypothetical syllogism would be something like this. If P, then Q. If Q, then R. Therefore, if P, then R. Note that it's like a chain. You're going from P to Q, from Q to R. And therefore, you can make a shortcut and go straight from P to R. Right? So essentially what you're saying is from P to Q to R, and then you just eliminating this middle step. Again, this is another valid form of hypothetical syllogism. Okay, so next one is disjunctive syllogism. We did, again, go over it before. Note that this is something like this, either P or Q, and then you can say not P or not Q, and what would follow? Well, the other one which will be left, because you essentially eliminated one of them. So this is DS, disjunctive syllogism. Based on the rules we just learned, you can also understand the next one, which is constructive dilemma. Constructive dilemma is if you have a conjunction of two conditional statements followed by disjunction. So if P, then Q, and if R, then S. This is the letters in the book. Of course, you can use pretty much any letters. Okay, once you put that as your first premise, your second premise will giving you a disjunction, either P or R. Note that you already said if P, then R, then Q, sorry, and if R, then S. So now if you have either P or R, what would be your conclusion? Either Q or S, based on the rules we just learned. Again, you can actually validly derive it for yourself if you don't believe me. You can go through it with truth tables and see that it is actually valid. And indeed, it is valid. Now, similar to that, disjunctive, destructive dilemma. Destructive dilemma is very, very similar principle, except now we are using another rule we just learned. So instead of going to antecedents, and therefore it would have to be one of the consequents, you go with two denial of two consequents. And based on that, if it's either not Q or not S, then it would again have to be either not P or not R. Okay, so this is this destructive dilemma, DD. This is how it goes. Okay, so those were all the valid forms. You should also know two invalid forms. Again, remember, we started with modus ponens and modus tollens. Modus ponens, if P then Q, P therefore Q, and modus tollens, if P then Q, not Q, therefore not P. They're both valid. Know that you can also do two other things here, can't you? Can you think about that? What two other things you can do? So instead of if P then Q, P, Q, you can try to go the other way and say not P, therefore not Q. You see the difference? So you're saying if P then Q, not P, therefore not Q. It may seem like this is a kind of a valid way to go, but it actually is not. Denying the antecedent, dA, that is invalid form. The result will be invalid. And the other invalid thing, as you hopefully also can see now, which you can try to do, is to do this, to go backwards, to say if P then Q, Q, therefore P. And again, that is an invalid form because this is your consequent, it is affirming your consequent, AC. That is another invalid form. Both of them are invalid. And the book gives pretty nice examples to understand it. So in this case, it's something like this. If Napoleon was killed in a plane crash, then Napoleon is dead. Is that true? Well, yeah, of course. If he killed in a plane crash, it is true. He is dead. That is also true. He's been dead for a couple of 100 years now. Therefore, he was killed in a plane crash. I don't think so. I don't think they had airplanes back then. 200 years ago, no. They did not. No airplanes. So you see, the logic here is flawed. Even though this is true and this is true, this is actually false. Similarly, in this case, it gives you a rather nice example too. Again, if Napoleon was killed in a plane crash, then Napoleon is dead. Napoleon was not killed in a plane crash. Again, this is also true. Therefore, he is not dead. Ooh, that is scary. He'd be like 200 and something years now. I'm pretty sure he is dead. He actually died on an island. Obviously not of a plane crash, but of something else, somewhat mysterious. If you want to go into history, you can read about that. For our purposes, it doesn't matter. But the point is, you can see how flawed the logic is in both of these cases. So this is the two examples of how these arguments do not work and why they are not valid. Invalid arguments. Okay, now a couple more important points before we try one of the examples in the end. Point number one, the order of the premises does not matter. They just have to be true. That's all we require of them. So, for example, this is valid. It may not look like valid at first, but if you actually switch them around, and if you write it like this, you will immediately see that, hey, this is disjunctive syllogism, a perfectly valid one. They're just the other way around. So if you see the premises which don't make sense, try switching them around. Same thing here. That is Modus Ponens. Nothing wrong here. One more point, and somehow students always get confused about that. Negation. Remember, we don't know the truth value. Negation just changes it to an opposite. So, for example, if G is true, then not G is false. But if G is false, then not G is true. So, if we have not G twice, does that mean it is true or false? It doesn't mean anything. It is just exactly the same as having G. If we have not H twice, doesn't mean anything. It is again same as H. So that actually is a valid form. If G then H, G, therefore H. But if you have negations, what does it change? Nothing. Absolutely nothing. The only thing you should look for, if it happens to be twice, one time it does not have a negation. If it doesn't have a negation, then it is the same as if it actually changed the sign. And therefore, this would be also the same as this. It's completely equivalent. It just means whatever it was here, true or false, here it will be the opposite. Okay? This is a very important point because you can get examples wrong, exercises wrong, if you do not follow this. Okay, this would be the last exercise, but just before we get there, let's remember our extra credit. So what should we do for extra credit? Okay, this is what information I would like to give you. I'm also teaching Philosophy 101 next semester, but I'm teaching it at Charleston campus. If you guys are interested, you can take any of these classes. Taking these classes are not going to be extra credit. Extra credit is going to be just that you know what I'm talking about. So message me this information, Philosophy 101, West Charleston campus, and that is enough for extra credit. However, if you do take them with me, I'd be very happy because I always like to see return students. It means they enjoyed the class, and it's a little bit easier for me if I know familiar faces. I don't have any problem with registration. I always have full classes, although who knows what will happen with current situation. But generally I don't have problem with that. However, I do like to see returning students. So anyway, for extra credit, just send me this information. That's the last extra credit. And now we can look at the example. What is the example? So this is one of the exercises in the end. It asks you if it's valid or invalid. Now, if you just look at it, you may be a little bit confused because remember, what is the valid form? The valid form would be either if P then Q, P therefore Q. The other valid form is if P then Q, not Q, therefore not P. Now, does this fit any one of them? No, the answer is it's not, because saying not M twice is pretty much the same as saying M. So that actually is an invalid form. This is affirming the consequent, which goes if P then Q, Q therefore P. See? Anytime you do these exercises, a good rule of thumb would be write it as P and Q and just take a note for yourself. For example, the way it was here, your Q would be not M, right? So you could write P equal W, Q equal not M, and then last one is again W. And then take a note where the sign changes in a way it's supposed to be. When you rewrite it in this way using this notation, that can help you to recognize whether or not it is valid. So do the exercises. Hopefully the exercises will be helpful. If you have any questions, please send me the questions. And again, you know now what the extra credit is. So hopefully you can use it and get your last extra credit, and that's it, I guess. I hope you enjoyed the class.